6, and then like maybe -5. Okay. And I'm doing this down here, not on the number line, because I don't want to distract from these numbers. These are the key numbers here, -3 and 5. Okay. All right. Now, this is what I'm going to say next is like, and I really want you to try to do this. We actually don't care what the value is when you test the number. We don't care whether it's 5, -30, a billion. We only care whether it's positive or negative. Did you hear that in class?
Yes, I think.
Okay. Because a lot of teachers don't talk about it that way, but really you only care about whether this x minus 5, x plus 3, when you try the numbers, I'm sorry. Did I get the x minus? Yes. When you try these numbers, we only care whether the result is positive or negative. Okay.
Okay.
So here's what I mean by that. Like you could come off to the right, and I'll do this here for x equals 0. You could do the following. You could say, okay, it's 0 minus 5 times 0 plus 3. And you could say, oh, that's -5 times 3, that's -15. Okay. But here's what you really care about. You care about that it's negative. Okay. And if you were programming, this was kind of wondering what your programming background is, if you've got any. When you're programming you develop rules, like, if it's a negative times a positive, it's always negative. Or if it's a positive times a negative, it's always negative. Or if it's a negative times negative, it's positive. Or it's positive times positive, it's positive. There's only so many cases. So you actually don't care about the number. You just care about whether it's positive or negative.
Yes.
Okay.
Sir.
Okay. And like we can get distracted here by actually trying to calculate it, but let me try. I'll make more sense on this next one. And again, here's how I do. Here's how I would tell you to do it. 6 minus 5 is positive. 6 plus 3 is positive. Positive times positive is a positive.
Right.
Now I don't even get the number. I don't care. You're gonna do this in calculus. You want to limit like how much you do, because there's a lot to do here. And then we try -5. -5 minus 5, -5 plus 3. -5 minus 5 is a negative. -5 plus 3 is negative. Negative times negative makes a positive. Now, if you really want the numbers, here they are. This is positive 20. But you don't need the numbers. You just need to know whether it's positive or negative. And it's generally positive times a negative, negative times a positive, negative, negative, positive, positive.
Right.
First two produce a negative, the last two produce a positive. Okay. All right, so you go back to your number lines. So like this is all kind of like work off to the side. And we kept our number line kind of clean. And what do we want here? We're going back to the original question. What do we want? We want it to be
greater than
0. Sorry, if you are eating, just let me know so I don't ask you questions and you don't have to answer awkwardly. I apologize.
No, I'm done right now.
Okay. We care about where it's positive and positive. Okay. So I'm going to shade those regions. It's all the numbers there and all the numbers in this green. Now, if you need to, and like first time you're learning number line, it's actually really helpful to have these there, but it starts at -infinity, goes to -3, 5 to positive infinity. And that's your answer. Your answer is -infinity to -3, comma, 5 to positive infinity.
Would it be don't we have to union or
It depends.
no.
It depends. Some instructors do this, some don't. Unions for sets, these are sets. I can go either way on them.
Okay.
I've seen both. So I don't know. If you get this far, you're doing really well.
Okay.
Any questions on that?
Yes.
Okay. What can I answer? What is unclear about this?
I have a question more on the notation at the end.
You mean the answer?
Oh yeah, the answer.
Okay. Yeah. Yeah. Go ahead.
In interval notation, right? It's soft bracket on the infinities, and then would it be hard bracket on the -3 and 5 because it's only greater than, not greater than or equal to?
Yeah. Let me summarize here. This symbol, this symbol, this symbol, this symbol, and this symbol, they all go together. And you throw in infinity, and negative infinity. These all go together.
Hmm.
Meaning like if it's a parenthesis, it's from a filled in, comes from this, the infinities. And then I actually like the words you used because it was said really well. I'm not quite as good at doing that, but the on the other side here, these all go together. You said soft
Hmm.
bracket, hard bracket. I like that because these are sort of acute. They're
Yeah.
rigid, and these are not. These are like more like a straw or something.
Yeah.
So the idea with what I've shown over here is that if you get a greater than or equal to, less than or equal to, which leads to a filled in bubble, which leads to a bracket, or if you're going the other direction, like these all go together, and then the ones on the left all go together, always,
Okay.
no exceptions. I don't know why it's not told more clearly, but to answer your question, at these points at -3 and 5, it is exactly equal to 0.
So
That's
it's
why
a
it's not. That's why it's not included. It's exactly equal to 0, which is not the same as being greater than 0,
okay
and that's why they're excluded because it's not. It's exactly equal to 0. Um,
every time.
yeah.
Okay.
Any other questions? Because that was a good one.
Um, no, I think that's good.
Okay, so we're gonna do 6 next. With this one, I'm gonna show you the alternative way to do it. That's a little faster. Maybe you'll like it. Maybe you won't. It's still some of the same first steps. So whenever you're solving an inequality or an equality, you really want zero on one side of the equation. This is
Okay.
just generally the case. Okay, so subtract 6, n squared plus 5n minus 6 less than or equal to 20. Okay, now can you factor this for me? Two numbers that multiply to -6 but add up to +5.
Um, oh, 6 and -1.
N plus 6, n minus 1. Very good. Now, what are the two places on the number line where it equals 0?
That would be -6 and 1.
Like this. Would you agree? -6 and 1. Yeah. So like
Yes.
the -6 on the left, on the right. Okay. Now, what did we do last time from here? Can you tell me in words what we did after we made the number line?
We tested each region of the number line, so like
Yes.
plugging in numbers on each side.
Yes. Now, your instructor may require you to do this. Let's just assume for the moment that they do not. They don't actually care. They just want the right answer. Do you remember
Like
what the shape of a quadratic looks like?
quadratic. That's the wait, the graph or the
Yeah, the
expression?
graph. The graph. What does a graph of a quadratic look like?
Like a parabola?
Parabola, U-shaped, and one opens up and one opens down. You remember that?
Yes.
How do we decide whether it opens up or down?
Um, the I forget what it's called, but the thing in front of the
Yeah. Does this one
square.
open up or down?
Up.
It does. So this in green is what the graph of the quadratic looks like.
Mhm.
What's going on there at -6 and 1? What can you tell me again what that means?
Um, they cross the parabola at 6 and 1.
At the x-axis, right? So over here on the left, do you agree that it's positive? It's above the x-axis?
Yes.
And between them, it's negative, it's below the x-axis.
Yes.
And over here on the right, it's above the x-axis.
Yes.
Yes. So you do not have to test points. If you know the shape of the curve, you can draw it and this will work. Now, I would encourage you right now to test a point in each region just to confirm that, even though you probably believe me. I would have you test like, let's have you test, I don't know, 3. 3 plus 6 times 3 minus 1. Is that positive or negative? 3 plus 6 times 3 minus 1.
Uh, 9 times 2 is 18, so that's positive.
Right. Positive times positive, so that's consistent. How about in the middle here? Let's try 0. 0 plus 6, 0 minus 1.
6 times -1 is -1. That is negative.
Okay.
And then -7 plus 6. That would be -1 times -8, so +8.
Okay,
Oh, wow. So positive, negative, positive. Yeah.
right. Okay. Now, this technique I showed you actually works for all curves, and it works in calculus. And it's not like a great like mystery revealed. It's just you're doing the exact same thing by testing points, but if you know the shape of the curve, you can use this approach where you don't have to test points. So it's up to you. Doesn't really matter to me which one you use. Your teacher may want you to test points, so keep that in mind. And we'll go from there. Now, this one wants where it's less than or equal to 0. Okay, so you were asking me before, because we want less than or equal to, and these are filled in, is it soft or hard bracket at those points?
Um,
I can go back up and show you the
Hard.
list. Yes. Yes. So it's bracket -6, bracket 1. So we say inclusive, meaning that these numbers are included in the answer.
Okay.
Okay. Now for the next one for 9, we can absolutely do it. Testing points. I just wanted to show you that. If we work together on calculus, like maybe when you're off in college, you know, you'll see the skin. You might even hear me in your head the next time. You're like, oh yeah, Matthew said that. I really like the graphical approach. So
Okay.
any questions on that or any follow-up, or can we move to number 9?
No, that works.
It works. Okay. All right, number 9. 15x squared minus 26x plus 8 less than or equal to 0. So notice that the right-hand side is already 0. Okay.
Yes.
And that's good. So we don't have to move anything. This is the harder factoring. Okay. Now, the first thing you always look for is a greatest common factor. And
Mhm.
this does not have one. Like there's nothing that goes into 15, 26, and 8 besides 1. So unfortunately, there's nothing we can do there. But if I were giving a test question like this, I would give the appearance that it was more difficult than it actually is to see if you remembered greatest common factor. So just be on the lookout for that. The second type of factoring, or the thing we're kind of drawn to, is the fact there's a 15 there,
Mhm.
and it's not 1. And that's bad. That's really bad. So that's tough case. So there's 2 approaches here. The first is like a guess and check, which I guess they don't teach anymore. I found this out a few years ago, which is fine. And the second is that's option 1, or letter A, we'll call it A. B, and B is you take the 15 and you multiply it by the 8. Which do you propose we do here? Kind of a guess and check approach, or multiply the 15 by the 8?
Multiply the 15 by the 8 because that's what he taught us in class.
Yeah. Now the problem is this gets really large,
Oh, yeah.
right? And you're like, all right, teach, we got a big number here. And I know like I really like making the list. Like I'm big on like being complete. Um, and like it may not make sense to you to include all of these when you know that they're wrong, but it builds you build up kind of this like tolerance for dealing with problems like this that are kind of a pain in the butt. And that's why I do it, so that I'm not surprised when I get this. And you can see I just did it while talking. I mean, it's
Yeah.
not impossible to do. Okay, but as a student, if you don't do this, you're really struggling. Was it that one? Is that one? And then sometimes you misremember which one. What am I even trying to do here? Because we're trying to actually get to minus 26. Okay,
Right.
which
So
is that one.
one of them has to be. Oh, yeah.
They both they're both negative because they add up to a negative.
Right.
And
Okay.
this is positive. Okay.
Okay.
So the reason you do that is you break apart the 26x into minus x minus 20x, 15x squared plus 8. Do you remember what to do from this point?
Um, you can factor each side by grouping. So it'd be like
Yes, exactly.
3x
Good.
equals 3x on one side times 5x minus 2.
Perfect. You immediately write that over here off to the right. The same thing that's inside parentheses, you immediately write over here. And and you're trying to figure out now, what do you multiply in to 5x and minus 2 to get back to the previous line? And it's usually a good idea to look at the the constant. Okay. All
Okay.
right. Like to get to 8, it's 4 times 2, but it's negative, so it should be -4. And then hopefully it works for the other one.
Right.
If it doesn't work, maybe you made a mistake over here, maybe you made a mistake up here. It's rare when these aren't like factorable if they're giving them to you on a test. And that's the whole point. I like to call this, it is factor by grouping, but I call it double factoring because you end up factoring at least twice.
Right.
Those come out and it's 5x minus 2, 3x minus 4. It's still less than or equal to 0.
Right.
So now you got to give me those 2 points that go on the number line here.
Give me 1 second.
Sure.
Okay, so the 2 points would be 2/5
Okay, I agree.
and then 4/3.
Okay, which goes left of which, or which one's right of which?
Oh, 2/5 goes to the left and 4/3 go to the right
Good.
because 4/3 is greater than 1.
Yes. Now, don't get caught up here on like, oh, every increment is 1. I mean, that's arbitrary. It really is. Like, you don't want to be that type of student because it really is arbitrary where these are. Like, so and I used to really struggle with this because I wanted everything to kind of be perfect, and it just doesn't work that way in the real world. So
Right.
just show their relative position, one smaller than the other. Don't even put tick marks in between, and you don't need 0. I know students, you want to put 0 in there. I'm not trying to call you out or anything, but it's like you don't even care. That's, I mean, it's not needed. It's just not
Right.
there. Now you said something really important. You said, oh, it's right in the middle. Well, if you're going to test a point, 1's pretty smart. The other thing is you never test fractions unless you have to. So like pick something, and if you're not sure what this is, like if you're stressed out because you're on a test or something, like pick 10 so that you know it's far away. Like don't even give yourself the chance that it's in the wrong region.
Got
Okay.
you.
Okay.
So,
So and if you're struggling with like, if you're not sure, just pick something really far away. Because it will work out. Might even give you some partial credit if you've made a small error somewhere else. Okay, so from here, what I'd like you to do is test these points or test other ones that you like in here and give me the signs in each of the region, please.
um, is -2 times -4, which is +8 for 0. For the 0 region. So that's positive. And then we said 1 for the middle. Yeah. 1. So that would be 3 times -1, which is negative.
Good.
And then do we say 10 or 20? 10.
You do 20. If you're not sure, do 20.
Okay.
Like really, like be as extreme as you think you need to be to get this.
Okay, then. 5 times 20 is 100 minus 2 is 98.
So this is where it's better to think of it as you said 98, but it's really a positive number.
Sure, yeah.
Because then, if you get 3 times 20, 60 minus 456, you're like, what's 98 times 56? The answer is it doesn't matter. It's positive. Positive times
Right.
positive is a positive. Okay.
Right.
Now, let me remind you that the graph of this original thing, it's a parabola that opens up. So while you did everything right and you did test points, I already know that the graph looks like this,
Mhm.
and that confirms what you just said. That it's positive on the left, negative, and then positive.
Right. Okay.
Now we want where it's less than or equal to 0. Okay.
Okay.
What would be the answer for that with the correct symbols? We'll say, what's the correct symbols? If you want to write it down or tell me verbally, either are good.
Less than or equal to 0 would be 2/5 to 4/3, right? That negative version.
Okay, what are the symbols though? What symbols go? Because you said
Oh,
the right. Because I presume you're not going to write this.
yeah, no.
Okay,
But
so give me a little more information there.
hard bracket 2/5, comma 4/3 hard bracket.
Good. Okay, so real quick here, let's just say this is -3 and this is -1, and I'm going to give you the sign chart here. So this is plus minus plus, okay, and we
Mhm.
want where, let's assume the problem is asking for where it is greater than or equal to 0. Can you tell me what the interval notation answer looks like, or write it down and then I'll write down the answer if it's unclear?
Greater than or equal to 0?
Yes.
Wouldn't that be -3? No, no, it'd be negative hard bracket -1, comma infinity soft bracket,
Okay. There's a
right?
reason I'm doing that over here to the right, because we read and we do math left to right.
Right.
So
I'm missing
what about this region over here?
soft bracket negative infinity, um, -3, hard bracket, and then
Yes.
upside down union, or is
Sure.
it still?
It's union or comma, but yeah, union's good. Good. Do you want us to, let's do one more of these. So this came from a problem. I mean, this is after you do all the work to get there.
Right. Okay.
All right. All right. So let's do another one here. Let's say you graph something and it's you know, -4 and 2, and it's negative plus negative, and we want to know where it is less than 0. Less than 0.
Okay. Less than 0. Um,
In other words,
the negatives.
yeah.
So that would be negative infinity. No, soft bracket negative infinity, comma -4, hard bracket. No, yeah, soft bracket. Union soft bracket negative or +2
Okay.
to infinity.
Yeah. Good. Okay. We've got some time. You didn't send over any questions from the second page, but we could look at those. Where should we go from here? What else can we do to help prepare you for your upcoming test?
I sent the problems in an earlier email, I think last week.
Okay. Can you tell me verbally from after from 11, starting from 11?
Starting from
Where should, yeah, so I see 3, 6, and 9, and we've done all those. We're
oh right, no, I meant can we do so in one of the emails I sent from January 16th,
sure. Let me go
I
find that.
sent 1.4. Can we go over some more word problems like the mixture and
Oh yeah.
kiss problems?
Yeah, those are horrible.
I want to get those down before the test because I'm
Yeah.
not doing well.
Yeah, it's better to just say I'm gonna get one of these than to, hope you
Not
don't.
have it.
Yeah. All right, I think we left off on some work problems.
Yes, I think so too.
Yeah, so I guess we'll start with those. Do you know if we did? I know we did. Let's do 37. Well, 37 is not a. Yes, it is. We'll do 38 and then we'll come back to 37.
Okay.
All right. So I gave you the shortcut last time, and I told you to think about these problems. Whenever you see working or work or jobs or time together, you want to think of it as 1 over the first person's time, whoever that is, which could be in this case, Pat, plus 1 over the second person's time, which will maybe make that Mike, equals 1 over their time together.
Right.
Okay. So we had to figure out, well, what is it that we are given in this problem? So let's read it. Let's read it very carefully. Pat and Mike working together can assemble a bookcase in 6 minutes. Which of these 3 is it? Is that 6 minutes?
The third one.
It's the time together. Okay. That's good. It takes Mike working by himself 9 minutes longer than it takes Pat working by himself to assemble the bookcase. Okay, so let's assume that the first person that we don't know, who do we not know, Pat or Mike's time? Or both?
We know. We don't know either, but we know Pat takes 9 minutes longer, or Mike takes 9 minutes longer.
So we could call Pat's time T and Mike T plus 9.
Yes.
And their time together is 6. So you generally use plus, I believe. Confirm that here in a moment. You wouldn't go like Mike's T and Pat's T minus 9. You generally use plus for these. So just keep that in mind. That's a little wrinkle here for it. So here's what we've got. 1 over T plus 1 over T plus 9 equals 1 over 6.
Okay. 1 over 2. Yeah. Okay.
Okay. Great. So this one's different because the ones we did last week, like there was just numbers and you added them up and then you cross multiplied or canceled out. Here you've got to make a common denominator, at least on the left. Okay. And the shortest way to do that is to take this T plus 9 and multiply top and bottom by T plus 9. Take this T on the left here, multiply the top and bottom by T.
Right.
Okay, so here's what that looks like when we're all done. We get T plus 9 over T times T plus 9 plus T over T plus 9, and then we'll put the T out in front, equals 1 over 6. Now, it may be in past problems you've included the 6 in this, but we're not going to.
Okay.
I'll show you why in a moment here. So when we add the tops, you get 2T plus 9. Whoa, sorry, technology, a little lag here. Come on screen. So it's interesting. You can see my cursor, but on my side, my screen is all froze up. Issue. So T over T plus 9 equals 1 over 6. Now from here, this is where I like. Let me just be careful here. It's keep the bottom, combine like terms in the top. This is so from here. This is where I like to cross multiply. So I like to diagonally multiply here. Like that. Have you seen that before? Is that okay?
Yes.
Okay, so it's 6 times 2T plus 9 equals 1 times T plus 9. So on the left here, we can distribute in 12T plus 54 equals T squared plus 9T. It's always a question of which way do you move stuff? And the answer comes from, well, we really want a positive T squared. So we're going to keep this stuff on the right, and we're going to move the 12T right and the 54 right.
Okay.
Sorry, I didn't let you answer that. But there's always a reason. Now, if you don't like 0 on the left, because I don't, I find that incredibly awkward when 0 is on the left. So just remove it. Just put it on the right. You can do that.
Okay.
You really can. We get a little too caught up on certain things in math, but yeah, you can do that. So now you got to factor this one. Two numbers that multiply to minus 54, but add up to -3.
-9 and +6.
So t minus 9, t minus
+6.
sorry, +6. Very good. So the answers are 9 or -6, right?
Right.
And one of those is unreasonable because if we remember what we declared our variable to be, we said that it was Pat's time.
Right.
And so what happens in math is what we're doing here when we're making a common denominator is we're actually changing the space of the problem. We're taking it from what it actually is to another space. And sometimes the answers in those other spaces don't actually work back in the original. They call them extraneous, but it's not extraneous because it's negative. It's extraneous because this one on the left works and this one does not. It has nothing to do with the fact that it's negative. Don't ever think that because it's negative it's not working. It's because the 9 is the only reasonable number here for this problem. So 9 t equals 9. Mike is 9 plus 9 or 18. And I believe that's consistent with the answer space there.
Yes, that makes sense. 1/9 plus 1/18. Yeah, I think that's 1/6.
All right, so let's look at 37. So 37 is kind of it can be done as a job work problem like we've been doing, but inlet and outlet problems are better solved a different way. Okay, so an inlet pipe can fill a tank. So imagine you have a tank. We'll draw a tank here. This is our tank.
Awesome.
And you can fill it in 10 minutes. So that's coming in. But it also has a drain, which means that it drains out here on this side. Okay.
Okay.
I like the enthusiasm.
Sorry.
No, that's great. No, it's good. It helps me. I was before this lesson, a woman. It doesn't matter. The customer wasn't able to make it, but she asked me to do the problems anyway. To help her with her understanding. And it's way better when I have like a person to dialogue with than to just run through problems. So I appreciate that. So like some students get caught up here on like what's going on. We don't know how big the tank is.
Right.
Okay. But we do have some information that's kind of useful. Okay. And this is one of those problems where you end up looking for a least common multiple of 10 and 12 because it does help to know how big the tank is.
Okay. That would be 2 then, right?
That's the greatest common factor.
Oh, so the least common multiple is like multiplying them together and finding what's
Well, that's a common multiple, but it's not the least common multiple. Like 10 and 12. So 10, 20, 30, 40, 50, 60,
Mhm.
24, 36, 48, and 60. That's your least common multiple.
I see. Okay.
Right. So the idea here is that let me just read this one more time. Fill a tank in 10 minutes. Okay. So we're missing here is a rate. Like if we knew how big the tank was,
Then we could figure out.
right? So let's just say the tank is 60 gallons.
Oh, fun.
Least common multiple. Least common multiple. Like there's a reason we did all that. So your rate here is that is your 60 gallons divided by 10 minutes. So it's 6 gallons per minute going in.
Wow.
And on the way out, it's 60 gallons over 12 minutes.
So it's 5 gallons per minute.
Yes.
Wow.
Okay.
That's
Okay. Now, is more water coming in or going out?
more water is coming in.
Yes. So if you ever, used your bathtub, if you've got one in your house, that's why it fills up with water, even if the plug is open, or if the drain's open, it's usually the case that more water flows in than falls out.
Right.
Right. I actually don't even know why they're designed that way. There's probably a reason, but I don't know. It's not really important. But what is important is that more is coming in than going out. Okay, so there's this, and you see this in other classes, but your flow is your in minus out,
Okay.
6 minus 5. So there is 1 gallon per minute going in.
Right.
Like it's rising at a rate of 1 gallon per minute. Is that okay? Like, because in 1 minute, 6 gallons went in, but 5 gallons went out.
Right.
Okay. But what we care about is how much time it's going to take for the tank to overflow. All right. So, well, if it's a 60-gallon tank, like we just talked about, how long does it take to get up to 60 gallons if it's 1 gallon per minute?
Can you say that again?
So this thing is rising at 1 gallon per minute, and it's a 60-gallon tank. How long does it take to get 60 gallons if you have 1 gallon per minute?
1 hour, 60 minutes.
60 minutes. Okay. This is a little different than how we solved, 36 and 38, even 35. It's different. It's just an alternative approach to doing that. So do you want one like this, or do you want us to try a different problem?
One more like this.
Okay.
Sweet.
Okay. So let's say, do you want exactly like it, or do you want the one where it gets empty?
Let's do one where it gets empty.
Okay. So on the way in, we know that it takes, get the numbers right here. 10 and 12. Okay. Let's go. Sorry, I'm losing my mind here. Let's go 20 minutes and then 5 minutes. 20 minutes and 5 minutes. So it takes 20 minutes to fill it up, but only 5 minutes to drain it. Okay.
Interesting.
Yeah, I mean, these are situations that exist. So you convert these to a rate, but you need to have some idea of how big the tank is. Now, let's say the tank, you just multiply 20 times 5, because that does work. So let's say there's 100 gallons in here, 100 gallons of water.
That's a big tank.
Yeah. Yeah. I mean, you go, if you're aboard a submarine or a big yacht, I mean, that's probably not that big a deal. Now, you want to know gallons per minute. Okay. So you convert the 100 gallons over 20 minutes, and it's 5 gallons per minute on the way in.
Oh, wow.
Okay. But on the way out, it's 100 gallons over 5 minutes.
Which is
That's
20 gallons per minute.
And that's why it goes out so much faster than it comes in. 20 gallons per minute out versus 5 gallons per minute in. Okay. So what's the net rate? What's the in minus the out?
5 minus 20, which would be negative 15.
Yes. So every minute you lose 15 gallons, and you started with 100, right?
Right.
So you could make a table, or you could do some division, but at time 0, there's 100 gallons, but 1 minute later, there's 85. 2 minutes later, there's 70. 3 minutes later, there's 55, and so on. So the answer, though, is 100 divided by the 15.
Right.
And whatever that is, 20 over 3 minutes.
Interesting. Okay.
Yeah. So one one suggestion I have here is maybe ask about question 37 and see if your instructor does it the way I showed you, or if they show you it as a rate problem like we did up here. Both are correct, but maybe you can get a second opinion so you can see whether you like it, which way you like it or not.
Okay.
All right, so really quickly, and that's not any good. Let's go back. We gotta do a short one here. Let's do like a one like 22.
Okay.
Don't have much time here, so let's try that one. Okay, 22 says the sum of a number and its reciprocal is 10/3. So generally n is the number, its reciprocal is 1 over n.
Yes.
And this is 10/3. So now the question is how to go about solving this. We're going to do this kind of like we did the work problem here. We're not going to multiply everything by n. We're just going to make a common denominator. So we're going to multiply it on the left, both of these by n. Okay, so that's n squared plus 1 over n equals 10/3. And then you diagonally multiply here.
Cross multiply to
Cross
get
multiplier. 3 times n squared plus 1 equals 10n. Distribute, move over to the left, so you get 3n squared minus 10n plus 3 equals 0. You use that approach we talked about. 3 times 3 is 9.
Right.
Okay. -1 and -9 work. So that's 3n squared minus 1n minus 9n plus 3. Factor an n out of the first one. Immediately write that over here.
Meaning it's -3.
Yes, n minus 3, 3n minus 1. And you get n equals 3 or n equals 1/3. And there's your answer with that one.
Awesome.
Okay, so I know that went fast. I just wanted to get one more in there. So yeah, good. It would be good. Let me just stop recording here.